Welcome to myprojectbazaar.com. Here I am going to discuss about task allocation on non-volatile memory based hybrid main memory. Energy consumption is an important issue in designing embedded system. While the main processor has always been the primary energy consuming device, the main memory has become a sufficient energy dissipator in recent years. Investigations shows that main memory accounts for up to 40% of total energy consumption on modern server systems. Thus, optimizing energy consumption of main memory is crucial to the overall energy budget of the system. DRAM has been widely used as main memory of computer system for decades. Recently, several emerging non-volatile memory technologies such as phase change random access memory (PRAM) and spine transfer torque RAM has been designed. Compared to DRAM, these emerging non-volatile memories have more promising characteristics for future universal memory. PRAM has better power efficiency but shorter write endurance and long access latency. STT-RAM is faster than PRAM. The write endurance of STT-RAM is regarded unlimited as DRAM. Since non-volatile memory has disadvantages of long write latency and limited lifetime, it is not desirable to be directly employed as main memory. Otherwise, the system performance will be adversely impacted and life expectancy will be severely reduced. Recently, hybrid memory has become a hot research topic due to limited write endurance of NVM. Proposed different mechanisms to reduce writes on analyzed a PRAM-based hybrid main memory composed of PRAM storage with a small DRAM buffer. They showed that such an architecture not only has the latency benefits of DRAM but the capacity benefits of PRAM. This paper targets task allocations problem by hybrid main memory composed of non-volatile and DRAM. Compared to the conventional memory technology DRAM, the emerging NBM has excellent energy performance due to the ultra-low leakage power. However, most types of NVMs come with the disadvantages of much shorter write endurance and long write latency as opposed to DRAM. This paper explores task allocations problems on hybrid memory, which consists of energy efficient NVM and write endurable DRAM. The objectives of the task allocation includes minimizing the energy consumption, extending the lifetime, and minimizing the size. Now I am going to explain the flow diagram of our project. In the first stage, it gives the input instruction from CPU. After getting the instruction, it checking for each and every time limitations of each and every task from CPU and allocate initially from DRAM and PRAM extraction. After that, the PRAM extractor pages will be allocated for each and every task limitations. Then, from the sizes of each and every task limitations and the energy levels of PRAMs and the energy levels of DRAM, it will retransmit the task for each and every time limitations of the task. Finally, the optimized result will be provided for DRAM and PRAM combination. In this stage, it rearranges the addresses and reallocates the pages allocations for total memories to manage the task from CPU instruction. After that, finally, the pages will be updated in PRAM and DRAM. The final output will be get from the PRAM architecture. This was updated by updated page allocations in PRAM design. In the initial case, all tasks are assigned to PRAM at first, which will be lead to which is greater than PT and N which is greater than NT. That is, the power at which greater than the thresholding power and the total number of tasks is greater than the thresholding of total number of tasks. then the task will be largest or is migrated from DRAM to DRAM iteratively according to the sizes of the task. The migration will continue until both P is less than or equal to Pt and N is less than or equal to Nt hold. Thus it rearrange the task allocations and finally allocate and update the pages informations of total memories in PRAM architecture. Now I am going to explain the running procedure of our project. Here we view the internal architecture designs of audio schematic diagram, and finally we view the waveform structures of timing diagrams for our proposed architecture design. For that purpose, we first select the implementation option and select the main function and click check syntax and run it. To view any errors or warnings messages, this will be displayed in the console window. This will check each and every lines in our codings and displays the errors and warning report in console window. Then we can view the RTL schematic diagram by running view RTL schematic. This will generate the logical and internal architecture designs of our proposed architecture from our coding result and view the logical designs of our work. Now select Add and click Create Schematic. This is our overall schematic diagrams. Here the input pins are address input, RAM data input, clock, enable, and read enable, reset and write enable. The output pins are address output, F add output, that means field address output, RAM address, CAS, RAS, WE and address outputs. We can view the internal structure of our proposed architecture by double-click the item. This is our overall schematic diagrams of our audio design. Now we can view the technology schematic diagram by run the view technology schematic. Now click Add, click Create Schematic. This is our overall technology schematic diagram of our project. This will display us a buffer and LUT based architecture designs of our work. We can view the timing diagrams of our proposed work by select the simulation option, select the main function and run simulate behavioral model. This will generate a guide designs of ISC file, then displays the timing diagrams of our internal architecture designs. Here, the I representing input pins and O representing outputs and the black color representing the signal data of the internal structure. In the first stage, I give the clock initial as 0 and read as 0. The first stage, I enable the write option as 1. Afterwards, I give the reset condition and give the enable as 1. And I will give the address as this address will source the address from CPU. And this is the RAM data address. Then I use the enable for overall circuit design and use the ready state. Now just run for the time specified on the toolbar. After clicking it, it will display the output timing diagram. Now I can change the clock cycle at positive edge. In the initial case, it will be set as a reset. And I change the reset condition to 0 and use the clock period. After giving the clock enable as positive edge, this will generate the page numbers of our proposed run designs architecture. So I change the clock periods for particular iterations and this will display the address outputs from our output design. Afterwards, now I use the read option 1 and give the write option as 0. Now I change the clock period. This will give reading output and generates the RAM data address. So for each and every iterations, this will generate the RAM data output. Finally, we get the address from our allocated pages, and finally this will be displayed in that add out and then address or out. Thus we update the total overall architectures by using non-volatile memory and DRAM memory with the combination structure for task allocation. Thank you.